What are the dimensions of visual experience? Is it possible to express the content of consciousness in quantitative terms? Artists and painters have been doing this for centuries, using colored paint on canvas. The Impressionist movement especially seemed to focus on the subjective aspect of experience. Painting expresses visual experience through the wordless language of color and form. The only thing missing from a painting is the vivid sense of three-dimensional depth. So perhaps a diorama offers a better model of visual experience, with its three-dimensional foreground model in front of a flat backplane painting. When viewed through a frame or aperture that hides its connection with the rest of the world, the diorama can appear indistinguishable from an actual experience of a scene. The diorama captures the information content of experience. This highlights the fact that visual experience is spatially structured. For example, my experience of this auditorium is of a volumetric room-shaped structure. Now, advocates of direct perception will immediately object that it's not my experience that is spatially structured, but the room itself. This raises a central epistemological question, which is the choice between direct perception and indirect perception. Direct perception, or naive realism, is the view that the world we see around us is the world itself. Indirect perception, or representationalism, suggests that the world we see around us is not the real world, but a perceptual replica of that world in an internal representation. There is a third alternative, which is a projection theory, whereby experience is indeed a spatial structure produced by the brain, but that experience is projected back out of the brain to appear superimposed out on the world. Curiously, this most central question remains unresolved to this day, and all three alternatives are represented in significant numbers in this very audience. But one of these alternatives simply must be true, to the exclusion of the other two. And the issue is by no means inconsequential, because these three theories present very different views of what visual processing actually does. Let us begin with the causal chain of vision. Light from the world enters our eye where it is transduced to an electrochemical signal which is sent up the optic nerve to the brain. There it triggers certain patterns of electrochemical activity that somehow cause our experience of the world. So far, all three paradigms are in general agreement. It is in what happens next that the theories diverge. According to direct perception, the patterns of activation in our brain are causally responsible for the appearance of experience beyond the brain. But the experience is not itself spatially structured. It is only the world which it is an experience of that is spatially structured. This places the spatial structure of experience paradoxically at both ends of the causal chain, both as the source of the original stimulation and as the final product or output of the causal chain. It serves both as cause and effect. So, is the world that we see and experience part objective world and part subjective experience? If so, is there a way for us to distinguish the objective component of experience from the subjective component? It turns out that there is a simple way to distinguish them, and that is to simply close your eyes. The part of the world that continues to exist unchanged is the objective component, whereas the part that vanishes when you close your eyes is the part that is the subjective component of experience. The fact that the entire structure vanishes without a trace when we close our eyes is clear evidence that the entire structure comes at the end of the causal chain, which is a bit of a problem for direct perception. But direct perception fails catastrophically in the case of dreams and hallucinations, where a spatial structure is experienced that has no counterpart in objective reality. And direct perception also fails catastrophically in the case of visual illusions. It provides no ontology for the spatial structures that are so vividly experienced to exist. Projection theory was devised to rescue naive realism from these embarrassments by proposing that the spatial structure of experience is indeed constructed by the brain, but it's projected back out of the brain into the world, which is where it is experienced. The problem with this theory is that nothing physical is detected projecting out of the brain into the world. Max Wellmans, the modern proponent of projection theory, insists that nothing physical is projected. It is only experience that is projected, a non-physical quantity that is undetectable by physical means. But then the problem is that the projected entity is in principle inaccessible to scientific scrutiny. It is a theory which cannot be falsified because its prediction that nothing will be detected is identical to the null prediction that nothing is projected. Therefore, it is not a scientific hypothesis about how spatial experience arises from the brain, but rather it is a theory that banishes the most interesting and challenging part of the problem into a spirit world of ghostly structures that have no mass, occupy no space, consume no energy, and have no physical presence in the world known to science. Another, still more radical solution is eliminative materialism, that is, the theory that visual experience simply does not exist, or at least not in the form that we experience it to exist. For example, when we think we're having a spatial experience, we are actually having a series of brief and fleeting visual impressions that collectively promote the illusion that we are seeing a spatial scene. In other words, we cannot trust our experience to be as it appears to be. Evidence for the unreliability of introspective observation is seen in the fact that naive subjects are totally unaware of the loss of visual acuity in their peripheral vision, and are astonished to discover that they have a retinal blind spot. But those same naive subjects can be easily educated by the most convincing demonstration of all, introspective observation of their own loss of acuity in peripheral vision, and of their own retinal blind spot. So it's not introspection itself that is unreliable, but only casual introspection by naive observers that's unreliable. Critical introspection by informed observers, on the other hand, is in fact a reliable and valid source of information for both the capacities and the limitations of visual experience. While it is true that we cannot assimilate all of the detail in a visual scene like this cluttered bookcase all in one glance, the experience of glancing around the bookcase is nothing like a sequence of frames on a television monitor, but rather, each visual impression is perceived at the location it is perceived to occupy in the global framework of surrounding space. The inescapable conclusion is that visual experience is spatially structured. To deny the spatial aspect of experience is to deny the single most characteristic property of that experience, or what makes visual experience what it is. In fact, the eliminative hypothesis turns epistemology on its head and asks us to doubt the existence of the one and only thing that we can be absolutely certain to exist, and that is our own experience. Even in the case of dreams and hallucinations, I can be absolutely certain that I am having an experience, and I can be absolutely certain that that experience has the properties that I experience it to have. To claim that conscious experience is any different than it is experienced to be is a contradiction in terms. So, whatever your personal paradigmatic preference, there exists a spatial structure that appears at the end of the causal chain, and it is that structure that I propose to model. To a representationalist, this data structure can be considered a model of the sense data of experience, a direct computational product or output of the brain based on sensory input. To a proponent of direct perception, this same data structure can be considered a model of the objects and surfaces that would be perceived directly out in the world for a given sensory input. To proponents of projection theory, this is a model of the experience that is experienced to be projected from the brain out into the world. And for eliminative materialists, this is a model of the spatial experience which does not exist and is not even experienced to exist, but only seems to be experienced to exist. That is the structure I propose to model. Now, once we acknowledge the existence of the spatial structure of experience, how are we to model that experience in quantitative terms? One way is to build an explicit spatial diorama of the experience with explicit volumes and colored surfaces as they are experienced, or a volumetric digital data structure like the images used in MRI and CAT scan imagery. But there are many alternative ways to represent spatial information, and not all of them use an explicit spatial mapping. However, whatever the representation that is chosen, it is important to draw a distinction between abstraction and reification. For example, this entire Gaussian curve can be abstracted to the mathematical formula for the Gaussian curve, which in turn can be abstracted to the parametric values of its mean and deviation. The equation is a compressed or abstracted form of the shape that it defines. But the abstract formula is not to be confused with the shape itself, in which every point of the curve is present simultaneously and in parallel with respect to every other point. In order to reconstruct the whole shape, it is necessary to reify the mathematical formula by computing the value of the function at each and every location in x and y. The product of this computation requires an array z of xy to store the curve that is reified by the equation. A similar principle is seen in the practice of image compression, where a spatial image can be compressed to a much more compact or abstracted code. But the compressed image is useless in the absence of an image decompression algorithm to unpack that compressed data and to express it in explicit spatial form. The information that's saved in compression is encoded implicitly in the decompression algorithm, so the compressed image is an incomplete representation of the image that it encodes. A similar argument holds for a semantic network representation of a scene. For example, this scene here could be represented as a corner composed of two walls and a floor containing a table by a curtain. The walls have a striped pattern, orientation vertical, color blue and white with an ornamental pattern. The curtain is blue with wavy folds, the carpet is yellow, the baseboard is ornate, the table is walnut in the cabriole style with a small drawer that has a brass handle. Each of these features of the visual scene can be expressed by a node in the semantic network, and many propose that the visual cortex encodes a semantic network of this sort by a hierarchy of feature detector neurons. But the semantic network is an abstraction, not to be confused with the reified image that it represents in symbolic form. There is no question that some kind of abstraction occurs in visual recognition and cognition. But visual experience is not that abstraction. It is clearly a reified, spatially extended, volumetric spatial structure. The principle of visual abstraction is well known and embodied in many models of perception and consciousness. The inverse principle of visual reification, on the other hand, is perhaps the single most under-acknowledged and under-recognized principle of perceptual function. Evidence for reification in perception is seen most clearly in Gestalt illusions like the Caniza figure, in which a two-dimensional stimulus is experienced as a three-dimensional percept. The computational transformation of perception can thus be described as the transformation from a two-dimensional stimulus to a three-dimensional percept, in which every visible surface is perceived as a spatial continuum of perceived color. An even more impressive reification is observed in Peter Tsay's volumetric worm illusion that promotes this spatial percept, and Peter Tsay's sea monster illusion that promotes this spatial experience. It is clear that some kind of reification is involved in visual perception. How the visual system performs this remarkable reification remains a deep, dark mystery. But that it does so is an observational fact. Another observational fact of perception is phenomenal projection, or the way each visual impression appears in whatever direction we direct our gaze, giving the impression of a complete surrounding space, even though we only see portions of it at a time. Perception has a constructive or generative component that contains more information than the sensory stimulus on which it's based. Finally, perhaps the most bizarre of all observational facts of experience is the phenomenon of perspective, or how things in the distance appear smaller, even when we know that they are not actually smaller. This raises the urgent question: do objects in the distance appear smaller by perspective, or do they appear undiminished in size? It took me months of the most intense introspective observation before I could answer this question to my own satisfaction. Do the walls of this auditorium appear to converge toward the stage? Does the head of the person in front of you appear larger than my head up here on the stage, or do the heads appear approximately equal in size? It turns out that the answer is both. Things in the distance appear smaller, and at the same time they appear undiminished in size. This is direct evidence that experience has a variable representational scale, where the scale in a representation is the distance in the representation relative to the objective distance that it represents. Subjects were placed in a short hallway and were given 3 cardboard models. The subjects were asked to report which model appears most similar to their subjective experience of the surrounding hallway. The first model on the left, A, is a rectangular box of approximately the aspect ratio of the hallway. The second model from the left, C, is a perspective projection, like a photograph of the hallway. The third model, on the right, B, is intermediate between those two, being a solid volumetric model, but with some perspective foreshortening applied. Subjects report that their experience is like models A and B, not like model A or B, but most subjects reported their experience to be both like A and at the same time like B. How can this be? The explanation becomes clear when the subjects were offered a fourth model, D, which is a truncated pyramid just like model B, but with a pattern of grid lines superimposed on it. The subjects are told that the grid lines represent the perceived scale of the model. In other words, this is like an Ames room rendition of a rectangular room laid with a grid of identical square tiles. When offered, the subjects overwhelmingly picked this model as the most similar to their experience. The reason is that this model embodies the same duality in size perception that is observed in perceptual experience, where objects in the distance are in fact perceived to be smaller, and at the same time they are perceived to be undiminished in size, because the size scale itself shrinks with distance from the observer. In other words, subjects make use of a warped reference grid to make judgments of objective size in the warped subjective world. This is why the Ames room illusion works so well. The geometry of visual experience can be mapped out by standing on a long straight road that stretches to the horizon in opposite directions. The sides of the road are perceived to be straight and parallel and equidistant, and yet at the same time, they are perceived to meet at a point up ahead at a distance well short of infinity. And if you turn around, they meet at a point back there too. In other words, the road is shaped like the rind of a melon slice with two curved sides that meet at a point up ahead and back behind, while at the same time being straight and parallel throughout their length. This is direct evidence that the space of our experience is curved. What does it mean for a space to be curved? If it is the space itself that's curved rather than the objects in it, then it is the very definition of straightness that is curved along with the space. In other words, if an object, like this road, is curved along with the curvature of the space, then that object is by definition straight in that space. If you think that this explanation is paradoxical, that it contains a contradiction in terms, take a look at phenomenal perspective that embodies that same contradiction in terms, where parallel lines meet at 2 points while remaining straight and parallel and equidistant. We now see the reason for this warping of phenomenal space, because it allows an infinite external space to be encoded in a finite spatial representation. It is the means by which a finite mind grasps an infinite spatial reality. Now, to return to the epistemological question, how can perception be direct if what we see is a warped and distorted world when we know for a fact that the world is not actually warped? There's not even a one-to-one mapping between external space and our experience, because that requires a mapping from an infinite to a finite entity, which is a mathematical impossibility. Projection theory has a similar problem. How can experience be superimposed on the objective external world when experience has the warped geometry of perspective, while the world itself is undistorted and infinite in size? Surely the bizarre warp of visual space finally offers irrefutable proof of the truth of representationalism. The world of experience is not identical with the external world that it represents, but rather our experience of the world is a warped and distorted replica of the world in an internal representation. In other words, beyond the farthest things that you can perceive in all directions, beyond the walls, floor, and ceiling of this room you see around you, is the inner surface of your true physical skull. And beyond that skull is an unimaginably immense external world, of which all this that you see around you is but a miniature internal replica. While this can only be true in a topological rather than strictly topographical sense, it emphasizes the indisputable fact that nothing can possibly appear in our experience except by being first represented explicitly in the brain. The key ideas of this presentation can be found online. Google a Cartoon Epistemology. Or a more rigorous presentation can be found in my book, The World in Your Head, and in my paper in the Behavioral and Brain Sciences journal, Gestalt Isomorphism and the Primacy of Subjective Conscious Experience. Thank you.